The James Webb Space Telescope has unveiled the most detailed image of Proxima Centauri b to date, offering groundbreaking insights into this potentially habitable exoplanet. It invites us to embark on a cosmic journey, to explore the mysteries of Proxima Centauri b and uncover whether it might be a second Earth. This enigmatic world lies in the habitable zone of its star, Proxima Centauri, just 4.2 light-years away, making it the closest known exoplanet to our solar system. But Proxima b is no ordinary planet. Could it host oceans or even alien life? Its proximity and position within the Goldilocks zone stir our imagination. Yet, there's more to this star system than meets the eye. Proxima Centauri b shares its system with at least one other planet, Proxima Centauri c, and perhaps others still waiting to be discovered. The intrigue only grows deeper. Proxima b receives roughly the same amount of stellar energy from its red dwarf host as Earth does from the Sun. Could this indicate the presence of liquid water and possibly life? Venturing beyond our solar system, we step into a vast universe teeming with exoplanets. With over 200 billion stars, the possibilities seem endless. Some of these planets even drift through space without a host star, cosmic nomads in the galactic sea. Still, Proxima Centauri b stands out as one of the most captivating among them. A year on this planet lasts just 11.2 Earth days, and it orbits much closer to its star than Earth does to the Sun. One side of the planet is forever lit, while the other is locked in perpetual darkness, a stark duality that shapes its strange climate. Let's now shift our gaze to its star, Proxima Centauri. This red dwarf, also known as Alpha Centauri c, is part of the Alpha Centauri triple star system alongside Alpha Centauri A and B. Together, these stars form the closest stellar system to Earth. Alpha Centauri A and B make up a binary system, G-type and K-type stars that appear as a single point of light in the constellation Centaurus. They are the third brightest stars in our night sky. Proxima Centauri, the faintest of the trio, is a red dwarf located about 4.2 light-years from Earth. Its name, Latin for the closest, reflects its status as our nearest stellar neighbor. Discovered in 1915 by Scottish astronomer Robert Innes, Proxima Centauri is too dim to be seen with the naked eye, with an apparent magnitude of 11.13, far dimmer than the human eye's limit of 6.5. Yet its importance is immense. Red dwarfs like Proxima are among the most energy-efficient stars in the universe. Though they shine faintly, their internal convection allows them to burn steadily for trillions of years. Proxima is expected to remain on the main sequence for another 4 trillion years. Still, whether such stars can support life-bearing planets remains a subject of intense debate. Proxima Centauri is a flare star, prone to powerful bursts of radiation. Its habitable zone lies very close to the star, between roughly 0.023 to 0.054 Australian dollars, astronomical units. That puts any nearby planet, including Proxima b, at constant risk from violent ultraviolet and X-ray flares. These intense solar outbursts can strip away essential atmospheric components like hydrogen, nitrogen, and oxygen. So, even if Proxima b lies in a habitable zone, it might lack a stable atmosphere, a vital element for regulating temperature and supporting liquid water. Without it, the planet's surface would be exposed to lethal space weather, drastically reducing its chances of harboring life. In conclusion, while Proxima Centauri b may be the closest exoplanet with Earth-like potential, many factors challenge the idea of it being truly habitable. The dream of finding another Earth persists, but so do the mysteries that remind us just how rare and fragile life might be in the vastness of space. Proxima Centauri b may look Earth-like at first glance, but the reality is far more complex. Despite its intriguing appearance, scientists remain cautious. Many conditions make the planet hostile to life. The quest to uncover the truth about Proxima Centauri b is ongoing, and one of the most promising tools in this search is the James Webb Space Telescope, JWST. Launched in 2018 after years of anticipation, JWST is equipped to help determine whether life could exist on Proxima Centauri b. However, as is often the case in science, answers are rarely straightforward. To ensure accurate imaging, the telescope required numerous adjustments. As Abby Tabor, a theoretical physicist at Harvard, explains, If a planet like Proxima Centauri B can absorb light from its star, it can also emit it as infrared light. That's where JWST's strength lies. It was specifically designed to detect infrared radiation. It can capture these emissions from a planet's surface and search for indicators like water or atmospheric patterns. Yet, the mere presence of an atmosphere is no guarantee of life. An atmosphere alone doesn't make a planet habitable, warns Ed Turner, an astrophysicist at Princeton. He points out that Proxima Centauri B could be more like Venus, a world shrouded in a dense, toxic atmosphere with surface temperatures too extreme for life. Exploring Proxima Centauri B is full of challenges. Although JWST offers unprecedented observational power, other limitations remain. Budget constraints add pressure, urging scientists to find new, cost-effective ways to observe exoplanets like this one. But the potential payoff is enormous, the chance to discover life or conditions suitable for it on a nearby world. Proxima Centauri B is especially captivating because it's the closest known exoplanet to Earth. It orbits within its star's habitable zone and is roughly the same size as Earth, increasing the odds it could support life. Its proximity makes it an ideal candidate for interstellar study, as if exploring a planet in our cosmic backyard. Imagine what it would be like to explore this Earth-like world. While a human mission isn't feasible yet, future technologies are paving the way. At Voyager 2's current speed, a trip to Proxima Centauri would take around 75,000 years. But innovative ideas like solar sails offer a glimmer of hope. These ultra-thin, reflective sails use radiation pressure from sunlight for propulsion, eliminating the need for traditional fuel. This method could eventually send spacecraft toward the Alpha Centauri system, including Proxima Centauri. Still, such missions face limitations. An atmosphere doesn't necessarily mean habitability. Again, Venus is the cautionary tale. Fortunately, JWST is capable of detecting even faint infrared signals, as low as 5% the brightness of the planet's day side. That's particularly significant given how dim Proxima Centauri is compared to our Sun. If Proxima Centauri B were home to an advanced civilization, they might even use massive orbital mirrors to redirect daylight from the bright side of the planet to its dark side, an idea as imaginative as it is thought-provoking. The universe is filled with exoplanets of all kinds, from Earth-sized rocky worlds to enormous gas giants. Some of the most fascinating are the super-Jupiters, planets far larger than Jupiter itself. But Proxima Centauri B stands out for a different reason: its potential to teach us whether life exists beyond Earth. Gas giants, super-Earths, and the search for alien worlds. Among the most dramatic types of exoplanets are hot Jupiters, massive gas giants that orbit extremely close to their host stars, enduring temperatures so intense they can melt metal. Imagine observing one of these planets up close. Colossal storms raging under scorching heat. Beyond the giants lie Neptunian exoplanets, similar in composition to Uranus and Neptune. These include hot Neptunes and mini-Neptunes, smaller, tighter-orbiting cousins that remain shrouded in mystery due to the difficulty of remotely analyzing their atmospheres. Then come the Earth-like exoplanets, worlds that closely resemble our own. These vary in size from slightly smaller than Earth to more than twice its mass. A notable subset is super-Earths, planets heavier than Earth but lighter than ice giants like Neptune. One of the most fascinating discoveries in this category is Proxima Centauri B, orbiting the red dwarf star Proxima Centauri. Classified as a super-Earth, it's estimated to be about 7 times the mass of our planet. Though it orbits close to its star, its position might still lie outside the classic habitable zone. It also has a sibling, Proxima Centauri C, located farther from the star and taking about 5 Earth years to complete an orbit. Confirmed in 2020 using archival Hubble data, it adds more intrigue to the system. Even more captivating is the suggestion that Proxima Centauri B could be unusually reflective, possibly due to a ring system bouncing starlight back into space. In 2019, astronomers noticed a strange wobble in Proxima Centauri's motion, hinting at the existence of a third planet, Proxima Centauri D, a possible Mars or Mercury-sized world. Picture a night sky filled not just with stars, but with alien worlds, each boasting unique climate structures and orbits. The universe is bursting with planetary diversity. With thousands of confirmed exoplanets and new ones discovered regularly. This is a thrilling time to be an astronomer or planetary scientist. Though exoplanets are as abundant as stars, observing them is challenging. Their faint glow is often overwhelmed by the brightness of their parent stars. However, technological breakthroughs now allow scientists to directly image certain exoplanets. Those are large, far from their stars, and still hot enough to emit infrared radiation. Still, most exoplanets aren't found through direct imaging. Instead, astronomers rely on indirect methods, like detecting the subtle wobble of a star caused by an orbiting planet's gravitational pull, a technique known as radial velocity. NASA's Kepler Space Telescope revolutionized the field by using the transit method, spotting slight dips in a star's brightness as a planet passes in front of it. This method has yielded critical data on planetary sizes, orbits, and even temperatures. Here are some remarkable insights. Over 22% of Sun-like stars are believed to host Earth-sized planets within their habitable zones. The TRAPPIST, one system contains 7 rocky planets, several of which may harbor liquid water. Much like the moons in our solar system, many exoplanets likely host exomoons, natural satellites orbiting these alien worlds. With over 4,000 confirmed exoplanets and counting, hot Jupiters remain the easiest to detect due to their size and proximity to their stars. But many more types await discovery. At the forefront of this exploration is NASA's James Webb Space Telescope, JWST. Designed to unlock cosmic mysteries, JWST is providing stunning imagery and groundbreaking data. One of its most significant recent achievements was a first clear detection of carbon dioxide in an exoplanet's atmosphere, a planet orbiting a Sun-like star about 700 light-years from Earth. This milestone offers vital clues about the planet's chemistry and formation, fueling excitement in the global scientific community. As NASA Administrator Bill Nelson put it, this discovery opens an entirely new view of the universe. JWST has also delivered breathtaking infrared images, such as that of 110 IRS-4, a young stellar object illuminating a cool cloud behind it. The orange tones capturing the image highlight distant stars hidden by icy dust. This research is part of the Ice Age initiative, which explores how ice forms in space, from interstellar particles to icy comets. In another first, JWST imaged the structure of a dusty disk around a nearby red dwarf star in infrared, offering yet another glimpse into how planetary systems evolve.